Hi again, everybody. Continuing our tutorial of how to identify parts, components under the hood. Yesterday I made a couple of videos, and today we're going to go a little into other categories. Now, yesterday I explained about sensors and how to figure out which sensors are what. And as you see over there, these are called back probes. Back probes are the yellow ones that you put into the connector. I put 3 of them because I like to measure ground, 12 volts and 5 volts. Now you have to be careful how you put these back probes. You don't want to pierce the wires in the sensor. And yesterday we talked about how do I know it's a mass airflow sensor. We look for 3 wires, and here is the air chamber where the air comes in. This one over here is the intake air temperature. This one has 2 wires, so we know it's an intake air temperature, which has a reference about 5 volts. Now, yesterday I spoke about PCMs and things like that. PCM is the computer of the brain of the car. It adjusts the air-fuel ratio according to how much air is coming in. And the ratio that it wants is called 14.7 to 1 part air to fuel. It's called the stoichiometric ratio. So we want to keep it at that ratio of 14.7 to 1, and the computer adjusts for that. Right now we're dealing with, this is called the fuel injection system, called central sequential fuel injection system. And as I explained yesterday, when sensors are the inputs, these are the sensors. And I explained yesterday, this is the harness over here. This is the harness. And these are the inputs for the computer, how to fuel trim the air-fuel ratio. More air, more fuel. Less air, less fuel. So it looks at all the inputs. When the engine is in closed loop, it looks at the oxygen sensors. So, how to identify parts? So, as you see, yesterday I spoke about fuses and things like that actually. And the first thing is, I spoke about serpentine belts yesterday. And how do you know how to follow electrical wiring, harnesses, and things like that? Now, we look a PCM, which is a computer, and this is we spoke about yesterday, ignition control module, which gives you the spark. Here's the ignition coil right here. On the back, ignition coil right here. Ignition control module, this is ground. Here's a connector going to the control module. This is the module. And now this is the heater hoses. As you can tell, we look for a PCM. When we look for the PCM, which is the brains of the automotive, we're looking for something that has a shield. We're looking for something that has a lot of wires coming out of it. So if you look and you're not familiar with these things, and that's why I'm making this video, you're going to look for something that's on top. Usually, the PCM is on top. It needs air circulation. And when we look over here, we see the computer, the PCM in this case. It might also be called the ECM. So with Toyotas, it might be called the ECU. Regardless of the name they call it from the manufacturer, it has the same purpose. It's the computer. It controls the air-fuel ratio. Fuel trims, short and long, are controlled from the input of the sensors to tell it how much air is coming in. Then it can open and close the valves on the fuel injectors accordingly by something called pulse width modulation. Now, the computer is right on top over here of the recovery tank. If we're not familiar, like I said, with computers, things like that, we're going to look for something this has a heat sink, well, a heat shield, a heat sink to dissipate the heat. Number 1. And number 2, if you look in the back, there are a lot of connectors here. And that's how we can determine that it's the PCM. All these wires, sometimes they have over 200 wires. It's always on top. So that's, therefore, if you want to find the correct wire and you want to measure, let's say, the intake air temperature, it's easier to go to the intake air temperature, measure it over here, instead of looking at the PCM, where there's 200 wires. So you could go over here and measure 5 volts reference and the signal back to the computer. Remember, any sensor that has to do with engine performance goes back to this PCM right here. Therefore, this is the brains, and this can turn on the car, it can turn off the car. If the camshaft sensor, the crankshaft sensors do not show that it's rotating, by giving the inputs to the PCM, it'll shut it down. No reason to give fuel or spark if the crankshaft pulley is not turning, or the camshaft sensor is not turning. Therefore, this PCM will be identified by heat shield, by the case that it has, and also by all these wires coming out, as you can see. That's the easiest way. Now, the other part of the video, you saw I put all these back probes. These are called back probes over here. Yesterday, when I was mentioning about serpentine belt and things like that, I received an email. When you take things apart, as if you're going to take off the serpentine belt, and I went over all these pulleys and all what they are. Idler wheel, tensioner over here, down here, and tensioner down there. It is recommended by me, and I've been doing this for years, especially if you have a smartphone, to take a picture before you start loosening and taking things apart, detaching things apart. When you take a video like I do now, see, I can see the routing of it, and I can see how it's attached. I can take a picture of it. It's much easier for me to go and to put it back together. All I have to do is refer to my picture or the video that I just made, how everything is connected. Of course, you have a diagram here, a routing diagram. Usually you find it here under the hood somewhere, and it tells you the routing of the serpentine belt. But let's say if you're gonna take off a gasket, a head gasket, things like that, take a picture of it. Use this. We all have smartphones. Take a picture of it, or make a video of it, and then see how it's attached, and then that'll make your job much more easier. I've been doing this for years like this. To make a video of it like this, how it's attached, how everything is attached, the bolts. And the other thing is, when you take the bolts out, like let's say these are 13 millimeter bolts. These are 8 millimeter bolts, and I'll explain why I'm doing this. Take them out and put them in order, in reverse order. Therefore, when you're going to go and put it back, let's say I'm taking out this compressor, 4 bolts, and I'm taking out the thermostat, which is in there. That's the thermostat right in there. That's the housing. So if I take out a head gasket or more complicated things, I'm going to take the bolts in reverse order and put them back together. It's much easier like that than just throwing all the bolts out. Spread it out. It's much easier. Doing it in reverse order and put them in order the way you took it out. Then put it like that, and then in sequence, and then put it back. That's the idea of it. Now, as you see these tools that I have a clamp meter which I use to put around hard wiring. As you can see, a clamp meter. And a suggestion when to use or what to use the tools. If you need a 3/8 ratchet, let's say I'm doing a compressor, and that's why I put it over here. I have a deep socket over here with a 13 millimeter socket, and this is called a quick release. You could get it from Snap-on, you could get it from Craftsman, you could get it from Pittsburgh Tools, Harbor Freight. This will give you much easier leverage to take out and loosen the bolts. You can use it on calipers, you can use it on rotors, on brakes, where it's a little hard to unloosen things. This will give you the leverage. You see how long it is. if I take out this bolt right here, see, I can loosen it right here. It's loosened. Easy. Easy. Okay? So try to get yourself this. Try to get yourself this quick release, and it'll help you for the brakes, and it'll help you for other things. Other thing is, first, see, this is a 1/4-inch ratchet. These are when you have small bolts. This is a 10mm with an extension with a deep socket. And these are for small things like 10mm or 8mm, where you don't need that much torque to take out the bolts. So therefore, let's say if you have rubber hoses or plastic, they're not going to be torqued that hard, obviously. So therefore, start off with gaskets or whatever with a 1/4-inch ratchet. That way you don't damage gaskets and parts like that. Don't need to use 3/8 ratchet for these type of small bolts because it's not torqued that strong. 3/8 is, I said, for compressor, for alternator. You see, it needs more torque. Then you're going to use a 1/2-inch ratchet, let's say for lug nuts, because those lug nuts are torqued about 100 foot-pounds. So use the proper tools depending on how they are torqued. Anyway, I hope you enjoyed this video. I'm going to make more videos about identifying parts. And please subscribe to my channel if you wish to. And I want to thank all the views that have been increasing this last month. They've really been doing well. I like to thank the viewers. And please watch my channel, Automotive Electronic Schematics by Joseph. I would appreciate it. I'm sure you'll find something to your interest. Again, we're going to go all over how to identify parts. Thanks for watching.